Hey everyone, in continuation with the previous video, let us discuss few more examples under nomenclature. So in the previous video, we have learnt the basic rules for naming coordination complexes. We have seen some examples also. So here I have got you some more examples where the complex salt is quite different. Okay, so if you look at this complex salt, you have a cation and anion, both are complex ions only. Okay, so in the previous case we had seen the nomenclature of such salts, right? So you had a positive part and a negative part, where either positive part or negative part was counter ion. Counter ion is just some atoms or ions, isn't it? But here if you look at this particular salt, positive part is complex ion and negative part is also a complex ion. Okay, so let us understand how to name such complexes. Very important model. You can focus this models for competitive examinations. It was asked in the previous years, so focus more on this particular model. Okay, so here actually speaking, I will teach you a simple trick to name such compounds. This trick will work out in all the cases. Okay, fine. And you know what, the first written is always positive and the next written is always negative, guys. Okay, so this is our positive part. First written is always positive part, next written is always negative part. Okay, fine. So actually speaking here, you don't know what is the charge of these central metal atoms. So in the positive part, central metal atom is platinum. In the negative part also, central metal atom is platinum. Okay, so to name them, first we need to know the oxidation state of platinum in positive part and platinum in the negative part. Okay, so to find out the oxidation state of these central metal atoms, this is what the simple trick I am going to tell you now. Okay, you concentrate the second part of a complex. Okay, so second part, that is negative part, you concentrate. Okay, and see here, find out the oxidation state of this particular central metal atom in a normal way, in a usual way. Okay, so how do you find out the oxidation state of this fellow? So just consider this as X. Okay, plus of chlorine's oxidation state is -1 into 4. You will try to equate it for 0. Okay, so in this normal pattern, find out the temporary oxidation state of platinum. What we are going to find out is not actually a correct oxidation state. So this is just a temporary oxidation state. Okay, so you will get, what do we get? X minus 4 is equal to 0. So X is equal to plus 4 you had got. Okay, and this digit, whatever 4 is there, no, this you divide into two parts. Okay, so 2 plus 2 is 4, right? So divide into two parts in the sense 2 and 2. Okay, and take this 2 as a charge here. Okay, so this is a positive part, no, so plus 2 you put it above the bracket, and here in the second part, that is on a negative part, take the same digit, the other 2, but with a negative sign. Okay, so since this is a positive part, we had taken plus 2 above the bracket. Since this is a negative part, we had taken -2 above the bracket. So this is the charge of this positive part, and this -2 is a charge of negative part. That is what the meaning, guys. Okay, so if you know the charges present above the brackets, you can easily calculate the oxidation state. And mentioning oxidation state is compulsory in the name, right? So that is the reason we have used this trick. So hope you understood the trick. Just consider the next part, I mean the negative part. In a normal way, in a usual way, try to find out the oxidation state of PT. Okay, so this is not the permanent oxidation state that we found, it's temporary one. Okay, by normal method you find whatever the number you will get, divide equally. Okay, so you will always get a numbers like 4, 6, 8 like this. You will only get even numbers. You will not get odd numbers. Because some of them will ask me, ma'am, if we get x is equal to 3, how do we divide? How do we equally divide? 1.5 or 1.5? No. Okay, you won't be getting odd numbers, guys. You will always get even numbers. Either 4 you will get or 6 you will get maximum. If you get 4, divide 2, 2. If you get 6, divide that into, separate that into 3 and 3. Put plus 3 on the first part and minus 3 on the next part in case if you are getting 6. Now you had got 2, 2, right? So I had put plus 2 on a first part of a complex, and minus 2 on a next part of a complex. Okay. So this is how is a trick, right? Fine. And now let us try to write the name. This is a positive part. Always positive part's name have to be written first, right? And again positive part is in a complex form. So ligand's name we will write first. So the name of a ligand is amine, and you have 4 amine ligands. So we will start with tetraamine. Tetraamine. Okay. And look at here, next is the name of a central atom. Okay, central atom is in positive sphere. This is a positive part. So its name is written as it is. So we will write platinum. Platinum. Now open the brackets and mention the oxidation state of this platinum. And now we can easily find out the oxidation state because we know what charge is there above the bracket, right? So find out the oxidation state X. Okay, we don't know its oxidation state X. Okay, plus this is a neutral ligand 0 into 4. Equate it for this charge. Whatever is the charge we have put above, no? So equate it for that charge plus 2. So X plus 0 is equal to plus 2. That means X is equal to plus 2. Okay, so oxidation state is 2. Mention that in a Roman number. Okay, so positive part's name is over, guys. Tetraamine platinum 2. Now write the negative part's name. Okay, so little gap you give and start writing the negative part's name. So negative part is also a complex ion. So here also we have a ligands, Cl ligands, chlorido ligands, and mention with the prefix. 4 are there. So tetrachlorido. Little gap you give and write down tetrachlorido. And next, central metal atom's name. Now here platinum is in negative sphere, right? So we will write its name as platinate. Platinate. Okay. And now mention the oxidation state of this platinum in the brackets. So let's find out the oxidation state of this platinum X. Okay. So let me find out here itself. X. Okay. Plus, and chlorine charge is minus 1 into 4. I am equating for minus 2. So you have a charge on this complex minus 2. So I am equating for minus 2. So you will get x minus 4 is equal to minus 2. So that means finally x is equal to plus 2, isn't it? So this platinum's oxidation state is also 2 plus 2. So Roman number 2. Okay. So the name of this complex is tetraamine platinum 2, tetrachlorido platinum 2. Okay, so this is how you have to name such complexes. Okay, positive part is in complex form and negative part is also there in a complex form. Okay, double complex salt we say. Such kind of complexes are called double complex salts. So this is the way of writing names of double complex salts. Okay, fine. Now let us go for the next example. So I have got 2 more examples of double complex salt only. So let us find out the name of this particular salt. Like I told you, the first written one is always positive. So the next written one is always negative. And we need to know what number is there. Is it a plus 2 or plus 3? We should know that. If you know what charge is there above, only then you can find out the oxidation state of central atom. Oxidation state of central atom you must compulsorily mention in a name. Okay, so that is why this trick initially we are trying to use. So now what is our trick? use the second part of a complex, that is a negative part. Find out the zinc's oxidation state temporarily in a normal pattern. So let me consider zinc oxidation state as X plus Cl's oxidation state is -1 into 4. Initially I am equating for 0. So here x minus 4 is equal to 0, x is equal to plus 4. So this 4 divide exactly into 2 halves. So 4 I can divide into 2. So this complex, the charge of the positive complex is +2, the charge of the negative complex is -2. Okay, so 2, 1, 2 you put it here, the other 2 you put it here, but this 2 is always positive and this 2 is always negative. Okay, so we are done with the trick. Now let us try to write the name. Okay, so look over here, positive part's name we have to write first. So let me start with ligand's name. This is isothiocyanato ligand, isothiocyanato, or you can write it as thiocyanato N also, linkage ligand, right? You can write this as isothiocyanato or thiocyanato -N. Okay, and this is amine. Alphabetically A comes first. So first I will mention about amine. 5 is there, so prefix I will use pentaamine. Look over here, 2 times A I am writing. Okay, so most of them will write single A, but 2 A's you have to mention, pentaamine. Okay, and this is thiocyanato. You can write it as isothiocyanato also, no problem, but according to a new rule of IUPAC, I am writing it as thiocyanato, and linkage first N is mentioned, so linkage is through N. This linkage you have to mention whenever you write the name of ambidentate ligand. Don't forget to mention the linkage, that's very important. Okay, so now ligand's name is over. Central metal atom's name, chromium, it's in a positive sphere, so its name will be chromium as it is. Now in a bracket you have to mention its oxidation state. So calculate its oxidation state, very simple. I don't know chromium's oxidation state, so I'll consider it as X. Okay, and its charge is -1, so X -1 plus 0, it is a neutral ligand, so 0 is equal to, you are equating for this number, this charge, +2. Don't equate it for 0, you are equating for +2. So you will get X is equal to +2 plus 1. So X is equal to +3. So oxidation state of chromium is +3, guys. Okay, so I'll mention the Roman number 3. Okay. Now positive part's name is over, negative part's name we are trying to write. In the negative part, the ligand is chlorine, that is chlorido, so tetrachlorido. Okay, so here I will write, zinc is there, it is in the negative sphere, so ATE you must add at the end, zincate, and in the bracket its oxidation state. So calculate its oxidation state, X, 4 chlorido ligand, so -4, and I am equating for this charge, that is -2. So X is equal to +2 we will get, so 2. Look at here, both oxidation states are different. Chromium has got +3 and zinc has got +2. Don't think that you should have or you will have the same oxidation state. If you get 2 here, there also 2. If you get 3 here, here also 3. No, the concept is not like that. Okay, oxidation state can be changed. That's why you should always work based on a trick. Okay, first you find out what numbers are there above the bracket, what charge is there. Only then you find out the actual oxidation state. So otherwise you will end up in getting a wrong answer. Okay, fine. Now let us go for one more example. Okay, so here also same thing. First let us find out what numbers are there. This is a positive part, this is a negative part. Now let's find out what number is there. So we'll take this particular negative part and we'll work based on a trick. Platinum, let me take it as X, -4. I'll first equate for 0. So X is equal to +4. Divide this number into 2 equal parts, that is 2, 2. So that means here I'll get +2, here I'll get -2. Okay, fine. So now let's try to write its name. Positive part is this, first positive part's name, its name is chlorido, its name is amine. Alphabetically A comes first, so amine I'll start. So that is tetraamine. Okay, and 2 chlorines are there, so dichlorido. So platinum is in positive sphere, so its name is as it is platinum. And now its oxidation state, I'll calculate here itself. X minus 2 plus 0 is equal to plus 2. Okay, so this minus 2, if it goes this side, X is equal to plus 4 you will get. So Roman number 4. 4 is the oxidation state for platinum. So now let us write its name. Tetrachlorido. I'll write it down since I don't have a place. I'll write it down. But you have to continuously write. Okay, so tetrachlorido platinate, because it's in a negative sphere, no? So I'll write it as platinate, and its oxidation state, guys. See, X minus 4 is equal to, now I'll equate for minus 2. So X is equal to plus 2. So that is Roman number 2. So the name of this complex is tetraamine dichlorido platinum 4 tetrachlorido platinate 2. Okay, so this is what the name. And now coming to a fourth complex, which is very important. You should literally remember this complex. This is the formula of brown ring. This is a formula of brown ring. Okay, so in the practicals you will identify the nitrate group, isn't it, with the help of brown ring test. So the brown ring that is formed in brown ring test has got a chemical formula, this FeH2O5NO Okay, so only in this complex this NO is there, no? This NO is taken as a positive ligand. It has got a +1 charge. Okay, in all other complexes, look at here, in this formula also you have NO, but here NO's charge is taken as 0. It's a neutral one. So when I spoke about NO, I told this point. One and only in brown ring complex, NO is considered as +1, okay, positive ligand, whereas in all other cases NO is normally considered as neutral ligand. Okay, so now let us name this complex. Positive part is sphere, negative part is the counter ion, that is sulfate ion. Okay, so now its name is aqua, its name is nitrosonium. You have considered its charges +1, no? So its name is nitrosonium. So how do I write? Penta aqua. Okay, and Fe is in positive sphere, so I will use the word iron itself. Okay, sorry. After writing the name of H2O, now I have to write the name of NO, right? Since I considered NO as a positive ligand, its name is nitrosonium. Iron. And its oxidation state, very important. Calculate its oxidation state, that is X. This is a neutral ligand, 0. Okay, plus this is a positive ligand. We considered it as positive ligand. Its charge is +1. Then sulfate charge is -2 is equal to 0. So X is equal to +2 minus 1, that is +1. Yes, so +1 is the oxidation state of iron, guys. Many times question was asked on this complex. They'll either ask you the oxidation state of Fe, or they'll ask you IUPAC name of the full complex. Okay, so penta aqua nitrosonium iron 1 sulfate, counter ion's name is sulfate. Okay, so this is the IUPAC name of our brown ring complex. Okay, so now I have got another example where NO is there, but here NO is taken as a neutral ligand. Okay, so here positive part is counter ion, its name is potassium, just write it as potassium, don't add any prefix here. Now the negative part's name, alphabetically cyanido, C comes first. Okay, its name is nitrosyl now. So pentacyanide. After writing the name of CN, I should write the name of nitrosyl, right? So nitrosyl, ferrate, and in the bracket its oxidation state. Let us calculate. This is plus 3 potassiums, each potassium has got a charge of plus 1, so 3 potassiums plus 3 plus x minus 5 plus 0, equate it for 0. So you will have x is equal to plus 5 minus 3, that is x is equal to plus 2. Okay, so here oxidation state is 2, Roman number 2. Okay, so that's all about the different complexes and their names. So especially this model is very, very important. The trick, using a trick, okay, trick is just take the negative part and in the usual way calculate the oxidation state equating to 0. Whatever number you get, divide into 2 halves. So first number as a positive number for first part of a complex and next number give it for the next complex, so they are like charges. So this trick is to find out, you know, the correct oxidation states of central atoms later, because oxidation state has to be included in a name. Okay, so this model, and don't forget the brown ring case where NO is taken as a positive ligand. They'll either ask you oxidation state of Fe or the complete IUPAC name. Rest all the compounds, if NO is there, consider it as a neutral ligand. I mean its charge is taken as 0 and it is named as nitrosyl. When you consider this as a positive ligand, it should be named as nitrosonium. Okay, so these are very, very important examples. So now let us learn the opposite way. Opposite way in the sense, we will give you the name, you should write the formula of a complex. So that is very simple. Let us see with some examples. See guys, writing formula from name is very simple. See, first thing is you have to observe the name carefully. Tetraamine diaqua cobalt. Okay, so the first written is a Spear's name. So here we can understand that Spear is positive. So first you have to fill up what is there in a Spear. And look at here, 3 chloride. That means this is a counter ion, right? Counter ion comes outside the bracket. Counter ion is negative. That means it will come next. First thing is positive, next written is negative. Counter ion is chloride, just as of now mentions here. Okay, fine. Now fill up the things inside a square bracket. Look at which is central atom, cobalt, symbol CO. Okay, and now ligands you see, tetraamine, amine ligand is NH3. How many are there? 4. And aqua ligand, aqua is nothing but H2O. How many are there? 2. Di they have mentioned. Okay, so this is the core formula, main skeleton, right? So according to a name, we have matched and written. And now if you want to know whether this formula is correct or not, calculate the oxidation state of cobalt. If you are getting 3, the formula is correct. Okay, so let us check it out. Let us see oxidation state of cobalt here. X plus this is a neutral ligand 0 plus this is also a neutral ligand 0. This is Cl. I have written 1 Cl no, so I will take it as -1 is equal to 0. So here X is equal to +1 I will get. But what is there in a question? Oxidation state of cobalt is 3. What I got is +1. That means this is not a correct formula. I mean, you are not supposed to change anything inside a square bracket. Outside the square bracket, counter ions number you should go on changing. So adjust the counter ions number gradually so that you will get the oxidation state +3. Okay, so if I put 2 Cl, what do I get? -2 is equal to 0, X is equal to +2. Now also it is not correct. So I will put the number 3. So when I put 3 chlorine atoms, so I will get -3, so X is equal to +3. So now this is a correct formula. So this is how, according to the oxidation state, you should go on adjusting the counter ions. You are not supposed to change anything inside the square bracket. So match the square bracket things as according to the name. Okay, but the counter ions number, in the name we never use the prefix for counter ion, right? So that's why keep this oxidation state in mind, and you know, till you get the correct oxidation state matching with this number, go on changing the number of counter ions. Okay, so this is how you have to write the formula when a name is given. So very, very, very important. So now let us work for the second question in a similar way. Okay, see, in a second question, potassium tetracyanonickelate, I mean potassium, that this is a counter ion is positive. So I will first write potassium symbol, that is K. And we don't know how many potassiums are there. That is yet to find, okay, based on the oxidation state. Okay, so let's now, as of now, keep just its symbol, that is K. So now open the square bracket, see what is the central atom, nickel. Nickelate they mentioned, that means nickel is in negative sphere. Okay, so that's why we are writing next. And see what ligands are there, tetracyano, that means CN ligands, how many are there? 4. So this is our core formula. Okay, now let us find the oxidation state of nickel in this pattern, whether it matches with 2 or not. Potassium, let me take it as 1 potassium I have written, no? So I'll take it as +1 plus X, and its charge is -1, so -4 is equal to 0. You will get X is equal to +3, guys. Okay, but I want 2. So what I will do, I will adjust the counter ions. 2. I'll take 2 potassium. So I will get 2 plus 2 here. So +2 minus 4, that is X is equal to +2 I will get. So this is the correct formula. K2NiCN4 is the formula that matches with this name. Okay, so go on adjusting the counter ion till the oxidation state of central atom matches. Okay, first you write the skeleton. See the oxidation state whether it is matching or not. Not matching, then adjust the number of counter ions. Okay, fine. So similarly, let us find out the formula for the third complex, tris 1,2-ethane diamine chromium chloride. Okay, so now spear's name is first written, that means positive part is spear. I'll open the square bracket. I'll write the central atom, that is chromium, symbol Cr, and ligand is what? Ethane 1,2-diamine, symbol En. How many are there? Tris they have mentioned, so 3. This is a positive part, and now it is chloride, Cl, and oxidation state 3 I should get for chromium. If I keep this formula like this, I will get 1 because it's a neutral ligand. So how do I get 3 when I have 3 Cls? Okay. Now fourth example. So there is no counter ion, nothing, just a neutral sphere it is. Okay. So let us open the square bracket and write the symbol of central atom, that is platinum. Okay. So that is Pt. And mention all the ligands, amine, that is 1 amine only, right, NH3, and 1 Br, bromo they have mentioned, and 1 Cl, chloro they have mentioned, and nitrito N. When they have mentioned nitrito N, you should write NO2. If they would have mentioned nitrito O, then you will write ONO. Okay, so there also you have to be careful. That's it. And see, if you keep this formula as it is, see whether you get oxidation state of platinum 3 or not. X plus this is a neutral ligand, this is -1, this is -1, this is -1 is equal to 0. So X minus 3 is equal to 0, X is equal to +3. Yes, you are getting oxidation state +3. Then this is a correct formula. Okay, fine. And now very important example from your NCERT textbook. All these are the different examples from your textbook itself. Okay, so this is one different example that is there in your textbook. Okay, so let us understand how to write its formula. First you write the skeleton, like normal skeleton as it is according to the names they have given. Okay, iron 3 hexacyanoferrate, that means here iron is a counter ion. Okay, this is a counter ion and this is a sphere. So iron, that is Fe, its oxidation state they had given 3 plus 3. Okay, so now within a square bracket, see what has to be written. Hexacyanoferrate, ferrate means again Fe. Hexacyano, ligand is cyano ligand, hexa they mentioned, so 6. So this is the normal skeleton, right? And now look over here, iron 3 they gave, that means see this valency of this iron is 3. So that one we will write it down like here. Okay, see normally Na2CO3, this is a salt we write. You know, this number is nothing but the valency of this ion, right? Yes, so why do we write 2 here? Because it is a valency. See, Na's valency is +1, CO3 valency is -2. So this number we write as a subscript for this atom or element, and this number we write as a subscript for this atom or element. Okay, suppose if I have to write the formula of aluminium chloride Cl, aluminium valency plus 3, Cl valency minus 1. So this number we write as a subscript for Cl, right? So AlCl3. So based on that, whatever its valency is there, Fe's valency, no, they have mentioned, that's why they mentioned it. So this valency I am writing as a subscript for this square bracket ion. Okay, so that is the thing. And now to adjust the number of counter ions, okay, so go on checking it, okay, cross verification method, right? And we know its valency is plus 2, right? So we know the iron which is there in a square bracket has got a valency plus 2, okay, and we should know how many Fe's are there, whether it is 1 Fe or 2 Fe, 3 Fe or 4 Fe, that we don't know. So to find out that, you know, let us cross check. Let me take this as x. So I should get the x value plus 3, guys. Till you get plus 3, go on working. Okay. So let me take it as x plus, and this is like its oxidation state I already know, plus 2. So 2 into 3, 6. Cn's charge is minus 1. Minus 1 into 6, 6 minus 6. 6 3s are 18, right? So minus 18 is equal to 0. So how much is the x value you will get? X minus 12 is equal to 0. X is equal to plus 12 you will get, where it is wrong, isn't it? X should be 3. Okay, so now it is wrong. That means you don't have one iron. Okay, so increase, put the number 2. So when you put the number 2, it becomes a 2x. Okay, so what you will get? 2x minus 12 is equal to 0. So 2x is equal to 12 you will get. So x is equal to plus 6. Plus 6 is also wrong. You should get actually plus 3. So now we can't put 2 also here. So increase the number. I'll put 3. So if I put 3 here, I'll get 3x. 3x plus 6 minus 18 is equal to 0. So 3x minus 12 is equal to 0. So I'll get x is equal to plus 4. Plus 4 is also wrong. So what I will do is I'll increase one more number. I will put 4 here. So if I put 4 here, it becomes a 4x. Okay. So now what do I get? 4x minus 12 is equal to 0. So x is equal to plus 3 I will get. That means this is the correct formula. Okay. So just keeping this oxidation state, we are cross checking it. Till you get plus 3, you are working with the number. First you have put 1. You didn't get 3. You had put 2. You didn't get 3. You had put 3. You didn't get 3. You had put 4. You got plus 3 as the oxidation state for this iron. So that means this is the correct formula. So the formula for iron 3 hexacyanoferrate 2 is Fe4 FeCN6 thrice. Okay. So this is what the formula that you can write. So this is how you can write the formula if name is given. So these are some NCERT examples. So you have many more examples under exercise. So open the textbook exercise part. In exercise part, whatever the questions are there relating to nomenclature, everything you can solve. I have almost solved some of the in-text questions and some exercise questions also. Remaining part is very easiest ones. So those easiest ones I am giving for you all to solve it. Okay. So the more questions you solve, the more confidence you will get in nomenclature. So this is all about the nomenclature. In the next video, we will discuss about the Werner's theory.